okay, so here's the solution. We take this set and we factor out the A pretending B is 0 and factor out the B pretending that A is 0, and we get that W is the span of the set, these two constant vectors. And we can go.
We found the span. So then from that solution, that because it has a span, it shows W is a vector.
We've written W as a span. We've shown it's equal to three linear combinations of two constant vectors. We've exhibited it as a span. We're sort of rewriting the definition as to show explicitly that it's a span, and then we appeal to the theorem that says, okay, any span's a vector space, so therefore we know that W is a vector space because it's the span of T. So we can go and try this with, on the same page, we can try this with B, which is the set A, 0, 0, B, such that A plus B equals 0, right? Well, this is a smaller set, right? So we can call this X.
I'm sorry, I just want to think about the last one. So we appeal to the theorem that any span is a vector space, so therefore
W is a vector space.
Therefore it's a vector space. So then did we show that it's a subspace?
Excuse me?
Did we show that it's a subspace?
Oh, no, we know it's a subspace because look, it is W is a subspace of M22 because, well, it's just all the possible things are 2 by 2 matrices.
Okay.
So we're writing down this, so that we write down, so here, X is a subset of M22, right? So because of the way you've written it. And this one, you can see also that here, that X is also a subset of W from the previous one, right? In other words, this is the set of all these diagonal matrices, but this is the subset of these matrices for which A plus B equals 0. So the question is this a subspace? So you want to do the same thing. Write X as a span, we want goal. Write X equals span of, say, R, and we want to know what R equals. So there's sort of a blank to fill in up here and a blank to fill in here. And I'll put this maybe over, so there's. So you want to do the same thing. Here is a linear system, so this is a restriction, right? So it'll be a two-step process in which you solve for a leading variable A in terms of B, remove the leading variable here in terms of the free variable B. That's called parameterizing the description. Because we're all just as a matter of convenience and sort of uniformity, we're always going to parameterize in terms of free variables when we have a system. Obviously, here we could parameterize in terms of the leading variable. You can solve for the free variable in terms of leading, and we get a slightly different thing, but that wouldn't do anything really different. So, are you guys, Catherine and Ramez, are you guys okay? Okay, good.